Hello everyone, welcome back to our Algebra 2 class. Today we are going to continue our conversation of Unit 5 sequences, and today we are going to introduce another type of a sequence which is called geometric sequence. In the previous lesson we introduced arithmetic sequence and also we practiced several examples about it. Today we'll do a similar thing. But before we start the topic, let's do a quick warm-up. As you can see, we have a definition of sequence defined in recursive formula, which was given the first term, and also remember, as I mentioned before, this is telling us how to get the next term from the current term. So n plus 1, this indicate the next term, and this is the current term. So we are going to find the next four terms, and we already know the first term is 1, so the next term, according to this one, 2 in the front, meaning 2 times the current term. So f of 2 is going to be 2 times the current term, which is 2 times 1, which is 2, right? So the third term is coming from 2 times the previous term, which is f of 2, so it's 2 times 2, which is 4. So we just continue doing this. As you can see, this is the current term, this is the next term, which is f of 4, so we need to multiply 2, which is, we get 8. And 1, 2, 3, 4. So the next four terms, we are going to get this. So now, since we have 5 terms, let's quickly write them down. So the first term is 1, 2, 4, 8, 16. Of course, we can't just continue forever, right? This is just how sequence works. So as you can see here, so this sequence, if you really look it closely, you will notice that the pattern of this sequence is, it seems everything is doubled, right? So we can just continue, the number actually increasing very quickly. And when we multiply a number, a constant number, to get next term, this kind of sequence is, yes, what we are going to introduce today, geometric sequence. So besides this example, let's look at this new example here. For this example, you can pause the video, think about what the pattern it is, but I know you already figure out, which is multiply 3, right? So this kind of sequence we call geometric. Apparently, a big difference compared to arithmetic. Arithmetic is adding a constant number. I mean, this number can be positive or negative, but this is, how we do arithmetic. But for geometric is multiply a constant number, and this constant number, we are going to have a new name for this. In arithmetic sequence, we call common difference, but for this one, we call common ratio, and we use R stands for that. So it's actually easy to understand because ratio is actually any two consecutive terms. If we just find the quotient between them, this is considered as ratio, then we can do that. So this number, common ratio, can be any number. It can be a positive number, can be negative, can also be a fraction, and sometimes can even be less than 1. So let's see another one. Let's see, sorry for my writing. So if we compare, this one is quite different, right? This one is getting bigger and bigger, but this new example here is getting smaller and smaller. So how do we find the common ratio for this case then? So some students might say, it seems like dividing 2. You're right, it's dividing 2, but when we say the common ratio, we actually need to figure out the number to multiply. So we are going to, what you can do is use a letter term to divide it by the previous term, which is 1 over 2. And whatever the consecutive terms you choose, you will get the same common ratio. So for this case, as you can see, is 1 over 2. So this one is getting smaller and smaller. So that's just different type of geometric sequences. Now, since we mentioned the arithmetic sequence before, so let's check the quick example. We have several sequences here. Let's check which one is geometric, arithmetic. I mean, if you have someone next to you, you can definitely discuss this with one you are talking to. So let's check the first one. So the first one, if we just look at the number, if you do not consider the negative symbol here, 1, 2, 4, 8, 16, apparently is multiplied the same number, right? But if you look closely, the sign is actually alternating, negative, positive, negative, positive, negative, positive. So clearly it's actually multiplied 2, but this time is multiplied negative 2. So this one is geometric. And this one, number is getting smaller, right? And if you look at closely, it's getting halved, right? So this is also geometric. At the same time, we're just going to put G here. And this one, negative 2, 0, 2, 4, number is getting bigger and as adding 2. So this is going to be arithmetic. And this one, from 1 to 2, can be plus 1, can be multiplied by 2, multiplied by 2, multiply 3, multiply 4. Apparently, this sequence has pattern, but it's not multiplying the same constant number, so it's not geometric. Apparently, it's not adding, so, oh, sorry, it's none, what I'm talking about here. So it's neither. It's not arithmetic, it's not geometric. This one. So as you can see, the number is not alternating between 0, negative 1, 0, negative 1, 0, negative 1. So this one is neither, because we cannot really follow any pattern here to figure out it's going to be adding or it's going to be multiplying. Okay? So that's just, a quick reminder to compare these two types of sequences. And sometimes you can see we can define a sequence, but we cannot, but sometimes the sequence not always fall into geometric or arithmetic sequence category. So very similar to arithmetic sequence, we also have two ways to define geometric sequence in either explicit formula or recursive formula. So we are going to quickly check how do we define them. So as I mentioned before, explicit formula is always using n to define something about an. So we just need to figure out how do we complete this type of formula. Let's check this example. This example actually 2 to 6 multiply 3, multiply 3, multiply 3, right? In order to figure out the pattern, let's check from the first term, how do I get the next one? So the next one, I'm going to use A1 times that common ratio R, right? I times once, I get the next term. And then, in order to get A3, I'm going to still using the first term, but this time I'm going to multiply R to get the second, then R again, in order to get the third. So this time I need to multiply the common ratio twice, which is R squared. Next, in order to get the fourth term, so as you can see, the pattern is actually we need to focus on how do I get any random term in the future from the first term. So R, this time I need to apply, when I multiply ratio once the ratio, I get a second term, third term, one more, I get third term. So in order to get a fourth term, I need to multiply the common ratio 3 times to get that. So if you notice that, just pay attention to exponents of the common ratio. You'll probably notice in order to get a random term, I need to multiply how many times of r? Yes, it's n minus 1. So this is our explicit formula. To get any random term in the sequence, we need to multiply the difference of the index number from the first one is n minus 1. Okay, so this is our explicit formula. As you can see, we need several things. The first term ratio and how many terms in here in order to get that term. So it's always the difference between that n minus whatever the term we have. This is the first one. Okay, now recursive formula. Sometimes you will be surprised, recursive formula can be very straightforward. So recursive formula is always defined as what is the first term, as you can see, which is 2, and how to define the next term from the current term. How? We need to multiply 3, right? In order to get the next term, we need to multiply 3. That's it. That's recursive formula. We always indicate the first term, and also we need to tell how to get to the next term. That's it. As long as you answer these 2 questions, that's our recursive formula. And in geometric sequence, since we always need to multiply a common ratio, first term, common ratio. So that's it. Since we always need 2 times common ratio, then that's it. That's how do we define recursive formula. Very straightforward, right? So this is just basic introduction for the geometric sequence. However, to help you totally master this type of sequence, I also prepare another video for some practices we can do together so you can have better understanding for that. So we are going to see you. I'm going to see you in next video. Thank you so much for checking this video and study this topic with me. Thank you so much and take care, everyone.